All right. All right. So number one, the first thing I'm going to do is I'm going to go ahead and write down the transformations for this graph. All right. So I have the amplitude is 2. The period of the graph
2 pi.
2 pi. Is there a horizontal shift? No, because the parentheses would be right here, and that's why they did not have to write them, just because there was nothing. But there is a vertical shift, and what is the vertical shift? Up 1. Okay, and we are making sure our headphones are out because we're being respectful, so both headphones are out. All right. So now we are ready to graph this. I'm going to grab my graph paper. No. Cheater McCheaterson. All right, we have an amplitude of 2, and we're going to shift it up 1. So I'm just going to make sure that my graph is big enough for me to have an amplitude of 2. So that means from the middle it's going to go up 2 and down 2. And then I need to be able to shift it up 1. So I'm going to go ahead and I'm just going to make my graph like 6 tall, because then it's plenty tall. And I'm doing this with the marker so that my, because we're about to draw a few things on this, so I'm doing it with my marker so that my x and my y-axis won't get confused with my actual graph. Okay? So maybe draw the lines with your marker, maybe draw the lines with your pen, whatever you want to do. For these, Miss Rice, can I do this on a sheet of notebook paper? No. This has to be done on graph paper. But Miss Rice, I'm really good on notebook paper. No. This has to be done on graph paper. But Miss Rice, no. This has to be done on graph paper. But Miss, no. Okay? Graph paper. No. Graph paper. Okay. So what we're going to do first, are we comfortable with the graphing method, or do we want to do it algebraically?
I like the graphing.
We like the graphing method because we're lazy. We like to do it quick. Okay. So the normal graph, I'm going to draw at the top of my paper. I'm going to remind us of what a normal sine curve does. So a normal sine curve starts at 0, and it goes up and comes down, and where it comes down, this is pi, and then it goes down and comes up, and this is 2 pi. That's where it ends. That's normal, okay? It normally goes up to +1 and goes down to -1. That is a normal sine curve, okay? So for our graph, we are still going to start and end at 2 pi because the period of the graph is 2 pi. But we're not going to go up and down to 1. What are we going to do instead? Up to 2, down to -2. Okay? So I'm going to take my pencil out because if I'm going to make a mistake, it's probably going to be right here in the beginning. I have to label my x and my y axis. So I know that I need to go up to 2 and down to -2. And I know that eventually I'm going to have a vertical shift of 1. So I'm just going to go by ones. 1, 2, 3. 1, 2, 3. Actually, this part you could still be marking in marker if you wanted. All right, and then 2 pi, I typically do my boxes in sets of 4 because when I do it graphically, I divide it in half and I divide it in half again. And sets of 4 are numbers that can be divided in half twice. So do we want to do 12 boxes or 8 boxes or 4 boxes? 8. Okay. 1, 2, 3, 4. I'm going to put a pi right there. 1, 2, 3, 4. I'm going to put a 2 pi right there.
Oh yeah.
Okay. So my graph is going to start at 0, and it's going to end at 2 pi, and it's going to cross in the middle at pi. Okay? So just like that parent graph for sine, we have a dot at the beginning, we have a dot at the end, we have a dot right there in the middle. Does that make sense? Okay? So I have beginning, end, I cut it in half in the middle. Now I'm going to cut these two in half, and typically we would go up to an amplitude of 1, but we are going to go up to an amplitude of 2. So I'm going to go up to 2, and I'm going to go down to -2. And I'm just going to lightly sketch this. There's my sine curve right there. I am making sure that this is not V-shaped. These are U-shaped graphs. So it's kind of like you have a bowl right here, and then you have a bowl right there. Okay? I've done it for a few years, you know, some practice. Yeah. Okay. So now our graph this is not our graph. This is very close to our graph, but this is not our graph. This is the graph of y equals 2 sine x. That's what we just drew. Now we have to do the vertical shift of up 1. Okay, so I'm going to take this point right here. I'm going to take a pen. I'm going to x out that point and move it up 1. I'm going to x out this point and move it up 1. I'm going to x out this point and move it up 1. X out this point and move it up 1. X out this point and move it up 1. Miss Rice, can I do it all at once and not in 2 steps? I don't know, can you? I can't. You're welcome to try to do that all at once, but it messes with my brain too much, which is why I do it in 2 steps. So if you want to do it all at once, you are welcome to do it all at once. Okay? Did that answer your question? Yeah, if you can do it all at once, all the more power to you, but it literally makes my brain explode. All right, and then what I'm going to do is I'm going to prove that I understand the pattern, and I'm going to draw an extra period of the graph. So I'm just going to be like, see, I got it.
Do we have to do it?
Yes. That's right, so I have to use graph papers? Yes. Do I have to draw 2 of them? Yes.
That's right.
Okay. Now, you know you got it right if you can trace it with your finger and it goes up, down, up, down, up, down. Okay? If your finger stutters at some point, it means you did it wrong. Your finger should be able to go over a smooth curve. Up, down, up, down, up, down. Okay. How do we feel about number 1?
Easy.
Those okay? All right, let's look at number 2 because I think that I threw something at you that's maybe going to startle you a little bit. So if you look at number 2, this problem could also be written as y equals sine of 1/2 x minus 2. So x divided by 2 is the same thing as half of an x. Does that make sense? Okay. Go ahead and work on number 2. Okay, so for number 3, it is a cosine graph. I already started it. I said my amplitude was positive 3 because the negative doesn't tell me anything about the amplitude. The negative tells me it's reflected. Okay, so my amplitude is positive 3. The period is 2 pi divided by 4, which is pi over 2. And then we do know that we have a vertical shift of down 5. Okay. So on the top of my paper, I'm going to go ahead and draw the cosine curve. And just a reminder, cosine curves and sine curves in the big picture perspective, they look the same. They go up, down, up, down, up, down, up, down, okay? But a cosine curve just starts in a different place. That's what makes it look a little different when we start graphing it. So a cosine curve starts up at positive 1, and it goes down. And in that down spot, it's at pi. You see that? So it goes down to negative 1. So it's just like a sine curve where it goes up to positive 1 and down to negative 1. You see that? So it goes up to positive 1, down to negative 1. A sine curve starts right here. A cosine curve is like I covered up this part, and a cosine curve starts right here. You see the difference?
Yeah.
So a sine curve starts right here. A cosine curve starts up there. Okay? So it goes from up all the way down at pi, and then it goes back up to 1, and this is at 2 pi. It crosses the x-axis right in the middle. So this is at pi halves, and this is at 3 pi halves. Okay? So our cosine graph has an amplitude of 3, and it's shifted down 5. So this graph is going to have to use a lot of boxes, like up and down. We're going to need a lot of boxes. We're mostly going to need boxes going down. So I'm going to go ahead and draw on my paper. I need to have space to do an amplitude of 3, but then I have to be able to move it down 5. So I'm giving myself That way I have space to do an amplitude of 3 because I have up 3 boxes. And then after I go down 3 boxes, I still need 5 more boxes to be able to shift that entire picture down 5. So I need quite a bit of space here. Okay? So I've got 1, 2, 3. 1, 2, 3. -5, 6, 7, 8. That's right. So why did you label those? I don't know. Just felt right. Okay. All right. So the period of the graph is pi halves. We can do 4 boxes, 8 boxes, 12 boxes. What do you want to do?
8 boxes.
8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Pi halves. Okay. So a cos graph normally starts up at 1 and ends up at 1. This graph has an amplitude of 3, but it's also negative. So instead of starting up, it's going to start down. Okay, so we are going to start down at -3, and we are going to end down at -3. So start at -3, end at -3. A normal cos graph would dip down to -1 in the middle. Our cos graph is going to go up to, what's the amplitude? 3. Our graph is going to go up to 3 in the middle. 1, 2, 3. Okay. In the middle of these 2 points, it's going to cross 0. In the middle of these 2 points, it's going to cross 0. Now, I cannot make this graph look like a V because it's not a V. So this part right here is like half of a U. You guys see that? That's half of a U shape. This is a whole U shape. And then this is half of a U shape. Alright, how'd we do?
I don't understand why I started
Because it had -3 in the front. So normally we would have started up at 1 and up at 1, right? Start and end at +1. There's a -3 in the front, so we're going to start down at 3 and down at 3. So it flipped it, but also we knew that we had a stretch of 3.
How did you know it's
Because, so this is our highest, this is our lowest point, it crosses in the middle. Lowest point, highest point, it crosses in the middle. Okay. Any other questions on that I can answer? So what do we do with each of those points now? We move them down 5. So I'm going to put an X down 1, 2, 3, 4, 5. It's math art. And we're making sure that we have arrows on either end because it continues going. And we're making sure that when we trace our graphs with our finger goes up and down and it's a smooth curve. Our finger shouldn't stutter when we follow our curve. That means you made a mistake. It's like if you went like this. You know what I'm saying? Some students, they don't go up, down, up, down. It goes like up, up, up. You know, like your finger does something weird. This should be like rhythmic. Up, down, up, down, up, down, up, down. Some students will draw these curves wrong and not really realize they've drawn it wrong, but if you follow it with your finger, you should be able to feel it, that you drew it correctly. You're like, this class just got weird and new age.
Yeah.
Feel the math, class. Feel the math. So what I'm talking about is some people end up having curves where, hold on, let me draw an example. where they like did something like this, and they're like, there, that's a curve. But if you trace that with your finger, it's not it's you stutter in the middle.
Okay.
It doesn't go up, down, up, down, up. Okay.
Thanks for explaining.
You guys, I've seen it all. I've seen it all. Okay, I've seen curves where like it started up here and then they're like, that's right, that's 100%, right? And I'm like, no, it's not 100%. Did you fall off a cliff while you were writing that? No. Okay. All right. So we're still working. We're surviving.
What is the color of these?
You didn't mark it?
You gotta turn it blue. Now you got blue black and white.
Dang it. I thought I hit bombs. So for number 6, things get a little weird. We have an amplitude of 1, that's not weird. But then things get weird after that. What is weird about number 6? The pi halves in front, right? Have we had any that have a pi halves in front of the coefficient, or as a coefficient? No, that's kind of weird. So here we're going to say the period of the graph is 2 pi divided by pi halves. 2 pi divided by pi halves. And I am going to keep it, change it, flip it. Nope. The pi's cancel, and the period of the graph is just 4. There's no pi. Just 4. Plain old 4. No pi. Okay? So how is that going to change our x and our y axis? Yeah, the x-axis is going to be a lot nicer looking this time than it has been on the other problems, okay? It's going to just be regular numbers. What's the last shift that we have? Okay, so we're shifting to the left 4. Oh, to the left 2. So sorry. I was looking at this. I'm sorry. Now I'm just making up numbers. To the left 2. So sorry. Okay. So it's going left because it said plus. We do the opposite. All right, on our papers. And it reflects over x. Yes. Oh, we could write that. I need to write that for number 3 too. Okay. So I'm gonna go ahead and start drawing. I have an amplitude of 1, so that's not very big, but I do need to be able to shift to the left 2. So I have an amplitude of 1. I'm going to go ahead and go up to 2, down to -2. The period of the graph is just 4. So do we want to count 8 boxes and put 4, or do we want to count 4 boxes and put 4? Count 4 boxes? 1, 2, 3, 4. So this graph just looks a lot different because it doesn't have the pi's on it, but it's going to work out the same way. Okay? So we have a negative cos graph, and it has an amplitude of 1. So that means that instead of starting up at +1, we're going to start down at -1. Okay? So I'm starting down at -1, and instead of the end of the graph happening at 2 pi, the end of the graph happens at 4. So I start at -1, I end at -1. In the middle, where do I go? I bounce up to +1. And then halfway between these, I had to cross over the x-axis. Halfway between those, I had to cross over the x-axis. What a cute little curve. Boop. 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 Okay. And each of our points needs to do what?
Left 2.
Left 2. How do we feel about that one? We're okay? So on these, you can do them. You just you have to take your time, and you have to know what you're drawing ahead of time. Just be careful with them, and then we can do them. Number 7 is trying to trick you, so I just want to make sure that we can start number 7 correctly. So what is different about number 7 compared to the other problems we've done? Yeah, we see a horizontal and a vertical, so we're going to be moving left and right boxes and up and down boxes. There's one more thing that's in there that's different. The period is not factored out. That 4 is right next to the x. And we know that it's supposed to be factored out. So I'm going to put a 4 in the front. And then I know that inside I have x plus pi over 2, and that pi over 2 has been divided by 4. And if you have been divided by 2 and then divided by 4, what is that overall?
8.
Divided by 8. So if you've been divided by 2 and divided by 4, that's like being divided by 8. So this equation is actually 3 sine 4 parentheses x plus pi over 8 plus 1. Okay. Number 9 does something similar. So look at number 9. What should we factor out on number 9? The pi thirds. You guys see that? There's a pi thirds with that x. So here we have pi thirds divided by pi thirds, and what do we get? 1. Is that for school on Thursday?
That's for tomorrow, baby.
Oh my god. So and Friday too then, right?
Why on Friday?
Oh, for the election?
No, this is for the hurricane that's coming in tomorrow.
That's for the hurricane. Okay.
Yeah.
And then probably Friday as well, right?
No.
Just Thursday?
It's a fast mover.
Okay. All right. So anyway, does that make sense for number 9? Okay. So pi thirds divided by pi thirds will give you 1 right there. Okay. All right. So you're going to finish this, and I'm going to have a video for you. Okay.
How long is the video?
15 minutes.
Okay,